This is part two of me covering the horizon and showing what causes it and how it works. In part one, I claimed that the horizon does indeed rise to eye level, with a couple of important distinctions to be made. So I intend to go a little further into detail and to show demonstrations. The horizon is the farthest point in which the surface can be distinguished. It has nothing to do with a spherical Earth, though it can be caused from a dropping surface. Another important note, the horizon doesn't need to be way in the distance. Even up close, if you have a very low viewing angle, you will observe a horizon. It's been demonstrated several times. It's not Earth curve that causes a horizon. There's you a couple horizons in a few hundred feet. There's you a horizon in less than 50 feet. It's our vision that causes the horizon. Why are we continually having to point this out? This is no duh shit. The three factors that cause the position of a natural horizon is your limited viewing angle to the surface, refraction, and visibility or distance. And once again, the horizon does not rise to zoomed in eye level. So you see the white line sitting on the horizon in the distance. And you see the three 6-foot poles marking the observer's viewing angle. Now you see a fourth pole out in the distance, which you couldn't even see, and now you also start to see the 6-foot gap between that line and the surface. For example 2, I drew a white line on the horizon of this railroad. That is a spot where the cross ties can no longer be distinguished from one another. So we have a 4-foot observer height represented by the tops of these white poles. And as we zoom in, we see a fourth white pole in the distance, and we see the 4-foot gap and a mirage between the surface of the railroad tracks and the white horizon line. So for example 3, instead of using editing, we will use video zoom. Now once again, I draw the white line on the horizon, and then I remove it so you can see that it is indeed sitting on the horizon. Now when he zooms in, it reveals the gap representing his viewer height or the angle that he's aiming at. Okay, once again, it represents either the angle that he's aiming the camera or his viewer height if he is level.
The horizon does not rise to eye level. Samuel Rowbottom and Eric Dubé both claim the horizon always rises to eye level. This is a requirement for flat Earth. There's a Rowbottom in his book, Experiment 15, he called it, and a prediction for flat Earth. This is including refraction will make it higher, or sorry, less. Refraction will decrease it. The prediction for flat Earth is no more than 0.0417 degrees dip. So very close to zero. So that's the prediction for flat Earth. But what is observable reality?
McToon is so invested in the globe Earth he would rather lie than lose a debate. And I'm going to prove he's lying later on in this video. But first I'll point out his straw man, and he claims what the angle to the horizon should be on his version of flat Earth. And he also asked a question. So let's hear that question again.
What is observable reality?
So McToon asked, what is observable reality in reference to the horizon? Well, this is observable reality. Okay, with the unaided eye, the horizon will always be at eye level. But if you are looking through an auto level or a theodolite, or if you're looking at a zoomed in image, then this is what you will see. You will see a horizon moving around, demonstrated with this zoomed in time lapse of Skunk Bay. What MC Toon does is takes measurements and selects the ones that best fit his model, or uses other people's measurements that match his model and present them in debates as proof.
Well, observable reality from 46 degrees north latitude is that there is a 3.3 degree dip of the horizon.
So this is a theodolite app on a phone, and this is one of the quote-unquote measurements McToon claimed to have made himself. Well, first off, when I tried to use a theodolite app on my phone as proof, the Globers pitched a fit. But secondly, and more important, the horizon's position is marked by a hazy boundary, and distance or visibility is one of the three main factors of the horizon's position. But thirdly, let's look at his so-called proof. So he claims that this horizon matches a globe perfectly at this altitude with a 3.3 degree angle. So on the right it says elevation angle and it's 3.3. But if you look over to the left, it says the horizon angle is 0.1. So this hazy horizon is 0.1 or 1/10 of a degree off from horizontal. So McToon presented flat earth evidence, but I want to go over this one more time. You see the white line at eye level, and zooming in, we see the gap between the surface and eye level. And here, this is Skunk Bay again. I drew 3 lines and kept them in the same position to see everything moving around. But I think I've covered enough, man. This video is getting kind of long, so I'm going to do one more part. But thanks for watching. Please like and subscribe.